Okay, solving quadratics by a different method. We're going to solve by the square root method this time. Just a quick review with radicals though. If I have two numbers outside of the radical, I can multiply them together. If I have two numbers underneath the radical, I can multiply them together as well. So the 6 and the 12 are both underneath the radicals, so I can rewrite this as 3 square roots of 72. Now once I get to 72, I'm going to do a factor tree. I notice that is a 9 times 8. That's 3 and 3. And 2, 4, 2, and 2. So a pair of 3's come out, so I have a 3 that comes out. A pair of 2's come out. The 2 that didn't get a pair stays underneath the square root. Don't forget about taking the original 3 as well. Now I've got 3 numbers that are outside of the radical that multiply together to give me 18 square roots of 2. Okay, here when there's a fraction, a couple rules. One thing is you can break this up into the square root of the numerator over the square root of the denominator, so 5 over the square root of 3. Another thing is that you can't leave the square root of 3 in the denominator, so we're going to try to get that to be just a 3, not a square root of 3. And we're going to pull that off by multiplying by the square root of 3. Because that's the square root of 9, which gives me 3. Well, whatever I do on the bottom of my fraction, I also have to do that to the top. So on the top, 5 square roots of 3. Now this 3 and this 3 can't be reduced because one is inside of the radical and the other one is outside. So hopefully that helps you out a little bit. That's going to come in a little bit handy here. But solving with the square root is kind of like this. I want to get the squared stuff by itself. So I'm going to add 30, divide by 5, and get 20. So that squared is undone or reduced or simplified by taking the square root of course, both sides. Now, when taking the square root and solving by the square root, you need a plus or minus. And with a little bit of factor tree work, it's 2 square roots of 5. And there's my answer. Now, the reason for the plus or minus, I'll kind of go to this question. X squared is equal to 9. Well, is x equal to 3 going to work? Sure. 3 squared is 9. X equals negative 3 will also work because negative 3 squared is negative 3 times negative 3, also a positive 9. So that's why we got this plus or minus whenever we take the square root. Okay, I want to get everything squared by itself, so I'm going to get that by itself. I'm going to multiply by a reciprocal of that to both sides. And I am going to get negative 16. See, now we just got done working with complex numbers. Take the square root of both sides, and this is the reason why. The square root of 16 is doable. The negative means that there's going to be an I because you have a negative into the square root. And the square root of 16, just do that like you normally would do that and make it 4 with a plus or minus. Chances are it's probably plus or minus 4i is how you'd regularly see me write it. Okay, I'm going to add 2. 2 and 4i aren't like terms, so x is equal to 2 plus or minus 4i. Okay. Don't FOIL. You're going to make it a lot longer and more difficult on yourself. Leave that as x minus 2 squared. So when we get to this step, all I have to do is take the square root to bust that x minus 2 out of there. Okay, I'm going to work through a couple more. I'm going to go fairly fast. So if I go too fast, stop, pause it, whatnot. But I'm going to subtract 3 from both sides. Divide by negative 5, and you get x squared is equal to 12/5. Take the square root of both sides. Okay, so that's kind of like one of those practice problems we just did. I'll pull it off like that. And the square root of 12, if I do a factor tree, is 2 square roots of 3 over the square root of 5. Oh, by the way, I don't want to forget about my plus or minus. I can't have the square root of 5 on the bottom. It turns into a 5, so I need to do this. It's called rationalizing the denominator. Okay, and I get 2 square roots of 3 times 5 is 15, plus or minus. Okay, divide by a negative 3. Okay, x minus 2 squared equals negative 7. All right, I now take the square root and I will get an imaginary number, but the square root of 7 is still going to stay the square root of 7. Now, you could put the I behind the square root of 7 right there. I like to put in front just so I know that that I is not underneath that square root. Add 2 to both sides, and x is equal to 2 plus or minus I square roots of 7. Okay, just a couple more different inverse operations. So use subtraction, use division, so divide by the 7. It won't affect all that. Again, like I said, try to leave that as is, don't FOIL. Get x minus 2 squared equals 3. Take the square root. X minus 2 equals plus or minus the square root of 3. Add your 2. It's a lot like ones we've done before. Okay, but there's no I because there's no square root of any negative number. Here we go. I'm going to subtract 4, so x squared equals over 12 is equal to 2. This dividing by 12 is just taken care of by multiplying by 12. And you'll get your factor tree, and you get 2 square roots of 6. And don't forget the plus minus. So that is solving by the square root. Again, do not FOIL. Never FOIL when you're doing these. It's going to make things a lot longer than they need to be.